All right, good evening, everyone. We're ready to start. This is CAWASA Wednesday webinars for our water operators in the Caribbean. And this afternoon, we're going to continue where we left off with the Chlorine Institute, led by Mr. Marco Guzamn of the Chlorine Institute and Mr. Earl White. They were with us last week, and we had a very good time learning so much about chlorine safety. And so today we're going to be dealing with sodium hypochlorite, and they will expound on that. I saw that we had registered near 50 persons from as far north as Jamaica and all the way down to Trinidad. So over to you, Marco.
Yes, thank you, Ignatius. And just like we did last time, we're gonna talk a little bit about the Chlorine Institute, just in case some of you did not attend last week's webinar on studying on chlorine safety in water and wastewater treatment facilities. So we're going to introduce the Chlorine Institute and then we're going to provide an overview of some hypochlorite chemical and physical properties. And by we, I mean Earl, because he's the expert. He hails from Miami, Florida, works at Ally Universal Corporation, member company of the Chlorine Institute. He will talk about health effects, how exposure to bleach affects human health. And then he'll talk about a little bit also about the personal protective equipment needed to handle sodium hypochlorite or bleach. And he'll review safe handling practices, provide an overview of all the other additional courses, resources, and training that's available through the Chlorine Institute. So the Chlorine Institute is a non-for-profit technical trade association that was established nearly 100 years ago. A couple of years we'll turn 100 years. We do something that it's called, we maintain something that is called the Chlorine Emergency Plan, or CHLOREP, which deals with chlorine emergencies in the United States and Canada that come in through a call center called Chemtrec. And for those of you who were here last week, you know that we talked about Chemtrec to lengths, and it's a call center that activates the CHLOREP emergency network. They mobilize teams. Like I said, it's in the U.S. and Canada, but that telephone center is available for anyone worldwide. They operate 24/7. So, even though you may think, well, it's in the U.S. and Canada only, and they only respond to emergencies there, would they deploy teams in the U.S. and Canada, but they can also provide telephone help and guidance over the phone, and not just in English, but in over 200 languages. We're also going to be, the Chlorine Institute develops technical and safety-related publications. We have pamphlets that are free for anyone to download. We provide, trainings such as this one, videos. Some of the videos we'll see throughout this training. And we work with the various regulatory agencies in the United States, such as the Department of Transportation, the Occupational Safety and Hazard Administration, the Environmental Protection Agency, Department of Homeland Security. We do this to advance health, to advance and promote a safe environment, and ultimately to have safety and security around all the mission chemicals that are not just chlorine and sodium hypochlorite, but include other chlorinated compounds such as caustic, which caustic is one of the things that's used to produce bleach from when it's scrubbed. So handling sodium hypochlorite safely video. So this is a safety video that we're going to be watching.
Just before you move on, Marco, there seemed to be
Yes.
some static or some noise on the audio. I don't know if somebody has a microphone on. I can't identify who it is.
Yes.
But it certainly have some screeching background noise.
Yeah, I heard it too.
Yeah, there's a.
Yeah, almost like somebody's eating potato chips or something.
Yeah, but I can't. Well, everybody seems to be muted. I don't know what's the problem. Okay, go on.
Okay. Well, and at this point, I'm gonna hand it over to Earl. But this is we're gonna be watching a handling sodium hypochlorite video safely. Video that's a little bit okay, hold on. So let me just go ahead and play it. Hold on.
Supplemental to your employee training programs. Further information may also
Can you hear it?
No, you need to turn the audio up.
And the safety
How about
data
that?
sheet for sodium hypochlorite issued by
Good.
your supplier. This video is intended to address basic issues for industrial handling and use. See the manufacturer's recommendations for household use. Sodium hypochlorite has long been recognized for having outstanding disinfecting properties. It's an extremely effective disinfectant against virtually all pathogenic bacteria, fungi, and viruses. Some of the more common uses for sodium hypochlorite include treating swimming pool water, bleaching and disinfecting laundry, sanitizing and disinfecting food preparation and process equipment, healthcare facilities, daycare facilities, home and office environments, and in water and wastewater treatment facilities. This video will cover the following topics: chemical and physical properties, health effects and first aid, personal protective clothing and equipment,
I don't think the
safe
video
handling
is
and
playing.
storage,
Your
and spill.
video is not running.
It's not running now? Okay.
No.
The audio is playing, but the video is not running.
Okie doke. Well, we'll try again. Let me give it a shot again. Okay, we can get back to it in a little bit. I think I may be having some issues with one of the plugins, but in the meantime, I think in the meantime, Earl, if you want to jump into chlorine versus bleach, which is something that was discussed last time, but I think if we're remembering, but yeah, go ahead.
Not a problem. Go ahead. Click to the next screen if you would, please.
Yep.
So chlorine versus bleach. The UN number for chlorine is 1017. It's got this skull and crossbones at the top, and it's got the class number of 2 at the bottom. And it normally comes in either rail cars or 150-pound cylinders or ton containers. Bleach, the UN number is 1791. At the top of the diamond, you will see that it's a corrosive. It's a corrosive to metals and to human flesh. And it's classified as in class 8 on corrosives. Chlorine has a strong pungent bleach-like odor, where bleach smells like bleach. Chlorine has industrial uses and is shipped as a compressed liquefied gas. Let's see, and chlorine has a lethal exposure risk, and the chemical name for chlorine, of course, is chlorine. Now, we already said that bleach has a bleach-like odor. The household bleach that you typically buy is less than 6% in solution. The industrial strength is typically between 10 to 30%. And it's a high corrosive and irritant risk. The chemical name is sodium hypochlorite. And it should be noted that chlorine bleach is not liquid chlorine. A lot of people get that name confused, but we in the industry need to make sure that we are not calling liquid bleach chlorine. Next slide. So other common terms, as you can see, people call it different things. They'll give the NaOCl name for it. They'll call it bleach. They'll call it liquid bleach. They'll call it hypo. They'll call it sodium hypo. I just either like to call it bleach or sodium hypochlorite. Next slide. And we're looking at the National Fire Protection Diamond on the left-hand side of the screen. Bleach has a 3 in the health risk. It has a 0 at the top of the diamond in the fire, and it has a 1 in the reactivity diamond. So in the one on the right, we've already went over it. That's the UN number, 1791 for bleach. Next slide. Sodium hypochlorite production. Sodium hypochlorite is a solution made from reacting chlorine with a diluted sodium hydroxide caustic soda solution. And this is the chemical equation for it and everything, and just gives you a real simple form of how it's made. But please note, the formula above is not for on-site generation. There are additional safety considerations before anybody wants to consider making bleach. Next slide. Okay, uses of sodium hypochlorite. It's used for disinfecting, sanitizing of drinking water and wastewater. It's used in cooling towers to control algae and mold in them. It's used in swimming pools and hot tubs to keep them clean. It's used in restaurants and hospitals and food processing equipment to clean them. It's used in pressure washing. Bleach is a disinfectant. It's largely used in laundry also. Bleaching is used by the paper mills, the pulp and paper mills. It's an elimination and control. It controls mussels, mold, fungus, and algae. Note, product must be a registered pesticide for some applications. In the United States, most bleach manufacturers have to have a pesticide. So it has to be registered with the EPA. I don't know if that's the same in your guys' area or not. Next slide. Marco, you want to hit the next one?
Yes.
Okay.
Okay.
Well, physical properties, it's clear yellow to light green liquid. The decomposition rate increases at higher temperatures. So the hotter it gets, the faster it's going to get weaker. The freeze point is negative 29.7 degrees Celsius for 15.6% by weight. The specific gravity is typically 1.16 to 1.25. The pH is 11 to 13.5 in strength. Sunlight or UV light increases the decomposition rate. Next slide. As you can see here, the vapor pressure. You can see that vapor pressure will increase with temperatures. It's really not much different than water, but if you had it in a sealed bottle or a container and the temperature was to increase around it, you would see that the pressure in it goes up. It's like in a plastic container, you'll see it start to bulge, and it may even at a certain point blow the cap off the top of the bottle. The vapor pressure of sodium hypochlorite solutions are not significantly different than water. Above 90 degrees Fahrenheit, there is more potential for pungent odor than there is for anything drastic to happen. Next slide. Decomposition. The decomposition rate of sodium hypochlorite solution increases by a factor of 3 to 4 for every 18 degrees in Fahrenheit rise in temperature. And as you can see on the side, on the left-hand side, that shows you the strength. And so they're starting out with about a 13% in strength. And on the bottom is the amount of days. And on the far right-hand side, you can see the temperature. So as you can see, at 120 degrees Fahrenheit, that 13% bleach will not last 30 days. It's going to be down to almost 0 in strength. So the hotter the temperature, the quicker it's going to lose its strength. Next slide. Okay, chemical properties. It has oxidizing properties and highly reactive. Chlorine is liberated when in contact with acids or acidic compounds. It's not compatible with acids or acidic compounds. It's not compatible with chemicals and cleaning compounds that contain ammonia. It's not compatible with organic chemicals and chemicals or compounds, including oils, grease, fuels, insecticides, solvents, and solvent-based cleaning compounds. Most metals like copper, nickel, iron, cobalt, vanadium, and moly, can you say one? You have to excuse me, and their alloys, hydrogen peroxide, and it's not compatible with hydrogen peroxide, and it's not compatible with reducing agent. Oxidizing agents such as sodium chloride, it's also not compatible with. Next slide.
And at the bottom, just wanted to mention very quick, pamphlet 96, Appendix G, sodium hypochlorite and compatibility chart is available for anyone to download. That's a really good go-to source. And I don't know if you can you see the pamphlet on the screen?
Yeah, it's at the very bottom. So.
Oh no, the actual pamphlet. Because I think I'm actually the sharing. I think I'm just sharing the PowerPoints, not the actual video, not my entire screen. So what about now?
Right, now you're showing everybody your screen.
My screen, okay. So pamphlet 96 at the very one of the last sections at the end is the incompatibility. This is perhaps the best resource that we have as far as sodium hypochlorite is pamphlet 96, and it's available to for free download through the Chlorine Institute bookstore. So this is the sodium hypochlorite incompatibility chart, and these are all the incompatible materials and what the mixing may result in. So again, really good resource, and it's in pamphlet 96. So just sorry.
That's all right.
I wanted to share that.
Yeah, because the most important thing to remember is that one, we shouldn't be mixing it with anything unless we check to make sure it's compatible, seeing how it's reactive with a lot of other substances.
Okay. So environmental effects. I don't know if can you still see my?
Yes.
Okay.
We're still on an incompatibility chart.
But incompatibility.
Yeah.
A couple of windows open.
That is interesting. Okay. What about now?
No. Okay, you're back
Okay.
to environmental effects.
Okay. Environmental effects. Sodium hypochlorite is very toxic to fish and aquatic organisms. Other potential environmental effects, it does not persist in the environment naturally. So does not bioaccumulate in organisms, does not contribute to the ozone depletion or global warming. It does not contribute to photochemical smog creation, and it does not interfere with the endocrine hormone system in mammals. Next slide. Toxicology properties. Sodium hypochlorite may affect the body through contact with the eyes or skin, or by inhalation, or by ingestion. Occupational exposure limits. No OSHA personal exposure limit or any of the others. Let's see, the American Industrial Hygiene Association, though, workplace environmental exposure level, which is the WEEL for bleach, is 2 mg/M3 for a 15-minute work period. The chronic health effects are, it's not a carcinogen. It is not a reproductive hazard. Next screen. There we go. Eye contact. Sodium hypochlorite can irritate and burn the eyes. Very corrosive. It may cause corneal scarring and clouding and risk of blindness. Next slide. Picture of someone exposed to it. Next slide. Skin contact. Sodium hypochlorite is corrosive and can severely irritate the skin or cause burning pain, inflammation, and blisters. Skin damage may not be immediately apparent and may continue to develop over time. Next slide. Inhalation. Sodium hypochlorite can cause severe irritation of the nose, throat, and respiratory tract, can cause headaches and dizziness, can irritate the lungs, causing coughs and shortness of breath and pulmonary edema. When mixed with acids and acidic compounds, nitrogen-containing compounds such as ammonia or organics and fuels, it creates a violent reaction that releases chlorine gas. Next slide. Inhalation. Okay.
Sorry, ingest.
That's all right. Ingestion. Sodium hypochlorite is corrosive and can cause chemical burns in the mouth, throat, and digestive tract. Risk of perforation of the esophagus and the stomach lining, nausea, vomiting, and diarrhea, coma and death if you drink it. Next slide, please. This is a personal protective equipment that is suggested that you use. Everybody who deals with bleach or any hazardous chemicals should go through a personal protective equipment assessment of each job to decide what they should use. This is what has been found and recommended by everybody in the industry and by the Chlorine Institute. So you can go down there and it covers different areas like line breaks, what they suggest you wear. It'll cover material sampling if you're going to pull a sample. You know, like if you're going to pull a sample, they suggest you use a face shield and chemical splash goggles. And then you go on over and it says chemical protective gloves. You know, and some places may require you to wear an apron. So some places are going to have more than what is just listed. This is the minimum that you should consider. Let's see. Next screen, please. Eye contact. If you get sodium hypochlorite in your eyes, hold eyes open and rinse slowly and gently with plenty of water for 15 to 20 minutes. Remove contact lenses if present after the first 5 minutes, and then continue rinsing eye for 10 to 15 minutes. Call a poison control center or medical professional for further treatment advice. Reference the safety data sheet for the from the manufacturer for additional first aid information. Next slide. Skin contact. If you get sodium hypochlorite on the skin or clothing, take off the contaminated clothing, rinse skin immediately with plenty of water for 15 to 20 minutes, remove goggles. And it should be noted first that if you get it all over you, you want to leave the goggles on for the first rinse. Because if you take the goggles off, the goggles were protecting your eyes. It'll rinse the stuff from your head down into your eyes. So you want to rinse first, then remove the goggles, and then we'll call a poison control center or medical professional for treatment and advice. And we're going to say again, reference the safety data sheet from the manufacturer for additional first aid information. Next slide, please.
Before I move on to the next slide, Earl, just wanted to show all attendees what a safety data sheet looks like. This one is from Olin, a member company of the Chlorine Institute, but this is how it what it refers to for safety data sheet. It's usually has the identification, some hazard identifications, how to first aid measures, and the likes.
Yeah, they used to be called MSDS sheets, material safety data sheets. Now they're called safety data sheets in America.
Okay. I switched the slide to inhalation.
Okay, inhalation. Move exposed person to fresh air. If person is not breathing, call 911 or an ambulance, then give artificial respiratory, preferably mouth to mouth if possible. Call a poison control center or medical professional for further treatment advice. And again, we're going to say reference a safety data sheet from the manufacturer for additional first aid information. Next slide, please. Ingestion. Call Poison Control Center or medical professional immediately for treatment advice. Have exposed persons sip a glass of water if able to swallow. Do not induce vomiting unless told to do so by the Poison Control Center or a medical professional. Do not give anything by mouth to an unconscious person. Again, we're going to ask you to refer to the safety data sheet from the manufacturer for additional first aid information. Next slide, please. Transportation. Sodium hypochlorite, UN number 1791, is shipped in aqueous solutions ranging from 10% to 30% sodium hypochlorite. Department of Transportation, which is DOT, shipping name, hypochlorite solutions, sodium hypochlorite. It is shipped as a hazardous class 8 corrosive material, packing group, or 3. Marine pollutant, it's got an RQ, which stands for reportable quantity, and reportable quantity is 100 pounds. Typical bulk packaging, Department of Transportation 111A 100W tank car, rubber lined. DOT 412 tank rail car, fiber reinforced plastic FRP. DOT 407 tank trailer, rubber lined. And typically non-bulk packaging, polypropylene, polyethylene, and IBC drums and carboys. Next slide, please. Transportation continued. That just gives you an example of one of the tank cars. And the bottom right one gives you one of a tanker trailer for over the road. And the IBC is in the bottom left-hand corner. Next slide. Unloading operations used air compressor or truck or customer pump to offload. Unloading cargo tanks. DOT and Transport Canada regulations require a cargo tank to be attended at all times during unloading. That's 16.4.1 and 16.9.5. DOT regulations require that attendance during unloading must be achieved by one of 3 ways as long as certain criteria are met. 1, a qualified person who is alert, attends the unloading, and has an unobstructed view within 25 feet of the tank. 2, a qualified person observes by means of video camera and monitors or other instrumentations and signaling systems located at a remote control station, or hoses used for unloading are equipped with cable connected wedges, plungers or flapper valves located at each end of the hose that are able to stop the flow from the tank cars. Next slide, please. Unloading tank cars. Although not required for tank cars by current DOT regulations, in cases other than transloading, it is recommended to provide continuous monitoring of tank car unloading operations. Safety showers and eye wash facilities and PPE required at these locations. Use a pre-unload inspection checklist. The checklist should verify the labeling and level of the receiving tank, should verify the placards and seals and tank trucks and tank car numbers. It should verify the chemical names and the quantity delivered, addresses on the shipping papers, verify the integrity and labeling of all fittings and transfer lines, verify that the brakes are set, wheels are chocked, derailleurs are in place for tank cars, and appropriate caution signs are in place. Establish that the unloader is aware of the location of the nearest safety shower and eye wash. Next slide, please. Storage. Store in polyethylene FRP or rubber lined containers, room temperature or cooler. Venting systems must be in place to relieve excessive pressure or vacuum when filling or discharging. Inspection equipment noted in 49 CFR 180.352B for metal, rigid plastic, and composites IBCs. External visual inspection. Initially inspect after production and then every 2 to 2.5 years, starting the date of manufacture or date of repair. Internal visual inspection. Internally inspect every 5 years for cracks, warpage, corrosion, or any other defects that present an unsafe condition. Next slide. Storage system. Selection of piping and valve materials must consider needs for structural strength and chemical resistance. You can use lined steel pipe, and it has to be lined, versus reinforced PVC pipe. Utilize protective pump designs. Regularly inspect all transfer system components, including pump seals. Ensure proper functioning of safety interlocks on feed systems, preventing accidental mixings. Next slides. Factors affecting the stability of sodium hypochlorite. Strength of the solution. Lower strength of sodium hypochlorites are more stable. Storage temperature. Decreasing the temperature decreases the rate of decomposition. Concentration of sodium of some transition metal ions. Higher levels of these metals increases the rate of decomposition. Alkalinity. The strength of the alkalinity also has effect on the shelf life of it. UV light will degrade sodium hypochlorite. Storage in clean containers adversely affects the stability. The clear containers allow UV light to get in. Okay. Pamphlet 96, Appendix C, bleach storage guidelines. And that's all I can see on that. I don't know if there's another line underneath that or not. Yeah. But if you want to look at pamphlet 90.
This is Appendix C. Showing up on the screen. I hope you can see it.
Yep, it's up there.
Okay, it's up there. Okay, yeah. This is Appendix C, bleach storage guidelines. It starts with an introduction. So this could be a standalone document. You can sort of take it from this document and have it as a standalone document, because it starts with a very basic introduction with bleach is bleach, and then bleach stability, impurities, thermal decomposition, metal contamination, which Earl talked about, storage tank management, resources, and additional information. So it's that Appendix C could be a it's a three-page document that is standalone and very useful for as a guideline for bleach storage.
Yeah, and what should be noted also is that whether you're dealing with chlorine or sodium hypochlorite is that the Chlorine Institute has tons of information up there. So if you want to know what to store bleach in, they have a pamphlet that covers storage. If you want to know what kind of piping to use, they have a pamphlet that will go over different systems for you. So all that information is available. So if someone is working on a system, building the system, I would suggest that they go to the Chlorine Institute and look at those pamphlets. Next slide, please. Minimizing degradant formation. Okay, minimize storage time. Use the bleach as quickly as you can. You don't want to sit in a tank for years. The pH, the solution range of 11 to 13. Minimize the sunlight exposure by storing in opaque containers and or in a covered area. Solutions should be stored at lower temperatures. Every 5 degrees Celsius reduction in storage temperature will reduce the degradation formation by a factor of 2. Dilution significantly will reduce the degradation formation for products with higher concentration. It is recommended to dilute the hypochlorite solution with cool, softened water upon delivery, if practical for the application. Next slide. Sometimes we think that stronger is better, not all the time if you're talking about how long it's going to set in a storage container before you use it. So we got the accidental mixing video.
Let's see if you can hear it and see it as well. Be embedded here. Let me see.
This informational video is designed to increase awareness about the risk.
For some reason, the audio cut off.
Okay. Okay. Let me see.
And the video stopped.
This informational video is designed to increase awareness about the risks of accidentally mixing.
We're not hearing anything. We're just seeing.
Yeah, I'm hearing it.
You're hearing it?
Yeah.
You're hearing it? Okay.
This informational video is designed to increase awareness about the risks of accidentally mixing sodium hypochlorite with other incompatible materials.
What about now, Earl? Can you still hear it or not?
I can hear it now.
You can hear? Oh, you can hear it? Okay.
It represents a compilation of current experience and knowledge drawn from Chlorine Institute members. The video is intended for general awareness only and is not intended as a substitute or replacement for on-the-job training or written standard operating procedures, guidelines, or checklists. Sodium hypochlorite is commonly referred to as bleach. You may think there are some similarities between chlorine and bleach, and in fact you may have heard bleach being referred to as chlorine bleach or liquid chlorine. But it is critical that you understand that while chlorine is used as a raw material to produce bleach, bleach is not chlorine. First, they are placarded differently. The U.S. DOT classifies chlorine as a Division 2.3 poison inhalation hazard gas and bleach as a Class 8 corrosive, which have very different characteristics and hazards. One of the first things you need to assess upon arriving at an incident is the chemical involved, which will dictate what type of response plan you need to activate. Chlorine is shipped as a compressed, liquefied gas. The only time it arrives at a customer's facility in gaseous form is when it is a direct pipeline from the producing facility. Household bleach is always an aqueous solution. While the accidental mixing of sodium hypochlorite during delivery may not be a frequent event, it can result in serious consequences, such as severe injury. Sodium hypochlorite is highly reactive. When sodium hypochlorite is mixed with acids or acidic compounds, nitrogen-containing compounds such as ammonia, or organics or fuels, it creates a violent reaction that releases chlorine gas and, in some cases, explosive compounds and/or chlorinated organics. These can all result in serious injuries, including chemical burns and toxic gas inhalation. Unintended consequences can occur through accidental mixing. The mixing of sodium hypochlorite with an acid is very dangerous due to possible chlorine gas generation. Chlorine gas is a toxic inhalation hazard, TIH. The odor threshold for chlorine is 0.2 to 0.4 parts per million. Inhalation exposure to a concentration as low as 1 part per million may cause irritation of the nose, throat, and respiratory tract. Moderate irritation of the respiratory tract will occur at 5 to 15 parts per million. At 30 parts per million, there will be immediate chest pain, vomiting, shortness of breath, and cough. Toxic pneumonitis and pulmonary edema can occur following exposure to 40 to 60 parts per million. At 430 parts per million, chlorine gas exposure can be lethal after 30 minutes. Exposure to chlorine gas at 1,000 parts per million is fatal within a few minutes. Sodium hypochlorite is also not compatible with the following materials of construction: metals such as copper, nickel, iron, or cobalt. Copper, nickel, and cobalt and their alloys act as a catalyst for the decomposition of sodium hypochlorite. Nonviolent release of oxygen gas could cause overpressurization of closed vessels or systems. In this video, you can see on a small laboratory scale what happens when an acid is introduced to a quantity of bleach inside a fume hood. There is a violent reaction that generates heat and the evolution of greenish-yellow chlorine gas, which you can see accumulating in the flask since it is heavier than air. Because this was done in the hood and there is more chlorine produced than the flask can hold, you can also see some escaping out of the flask opening and being pulled up and away because of the fume hood's draw. The Chlorine Institute routinely analyzes incident data to find opportunities to improve and enhance safety in the chlor-alkali industry. Accidental mixing incidents are of particular focus and interest to the Chlorine Institute because of the serious consequences that have occurred from these incidents. Let's examine contributing factors in 2 case studies involving accidental mixing incidents.
October 21st, 2016. The MGPI processing facility in Atchison, Kansas. An unintended chemical reaction resulted in a dense cloud containing toxic chlorine gas and other chemicals that drifted into the community, leaving over 140 people with reported injuries. The incident occurred during a routine chemical delivery when 2 incompatible chemicals, sulfuric acid and sodium hypochlorite, were inadvertently mixed, forming the toxic cloud.
Delivery and unloading operations may be perceived as simple compared to other processes at chemical facilities. But because these activities can involve large quantities of chemicals, the consequences of an incident can be severe. Our case study on the MGPI incident stresses that facilities must pay careful attention to the design and operation of chemical transfer equipment to prevent similar incidents.
The MGPI facility produces distilled spirits, specialty wheat proteins, and starches. The incident occurred in a section of the plant that uses sodium hypochlorite, or bleach, as well as sulfuric acid. These 2 chemicals, when combined, can form chlorine gas and other chemical compounds. On the morning of the incident, a truck from a chemical distribution company, Harcross Chemicals, arrived at MGPI to complete a routine delivery of sulfuric acid. After reviewing paperwork in the control room, an MGPI facility operator escorted the driver to a locked loading area. There, chemicals are transferred from trucks into the facility through piping, called fill lines, to several large storage tanks in an outdoor tank farm. The MGPI operator unlocked the sulfuric acid fill line for the driver to connect the truck's unloading hose. The operator remembers pointing out the correct fill line to the driver before he returned to his workstation. The driver, however, does not recall hearing the operator identify the fill line. Unknown to the operator, the sodium hypochlorite fill line was also unlocked, and the two lines, which were only 18 inches apart, looked similar and were not clearly marked. The driver connected his truck's sulfuric acid hose to the sodium hypochlorite line, and sulfuric acid began flowing inside. He then returned to the cab of his truck. Shortly before 8 a.m., a greenish-yellow gas began flowing from the bulk tank of sodium hypochlorite. The driver noticed the cloud in his truck's side view mirror and attempted to return to the connection area to turn off the flow of sulfuric acid, but the gas overwhelmed him. He then ran to the passenger side of the truck to close a valve that could halt the flow, but he was prevented from doing so by the gas. Instead, he ran away from the cloud and escaped to a separate area of the facility. At about the same time, toxic gases entered the facility control room through the building's ventilation system. MGPI operators preparing for shift change in the control room were immediately overcome by the toxic gas. Because the operators had a practice of locking respirators between shifts, some were unable to access their respirators before evacuating the building. With no other way to stop the flow other than closing manual valves on the fill line or truck, or by triggering one of the truck's emergency shutoffs, the sulfuric acid continued to enter the sodium hypochlorite tank for nearly 45 minutes until emergency responders shut down the flow. Approximately 4,000 gallons of sulfuric acid combined with 5,800 gallons of sodium hypochlorite, causing a large, dense cloud containing chlorine gas, which soon drifted off-site. MGPI employees were evacuated from the site, and 11,000 Atchison citizens were advised to either shelter in place or evacuate. Over 140 people, including MGPI employees, emergency responders, the truck driver, and members of the public, sought medical attention, some requiring hospitalization.
The CSB's final report includes 11 key lessons and outlines clear safety improvements that can be implemented at similar facilities across the country. Among these are facilities should evaluate chemical unloading equipment and processes and implement safeguards to reduce the likelihood of an incident, while taking into account human factors issues that could impact how facility operators and drivers interact with equipment. As the CSB report details, the contributing factors included close proximity of fill lines for incompatible materials, indistinguishable fill lines for incompatible materials, insufficient pipe marking and labeling, insufficient and inconsistent unloading procedures, including no practice of identifying procedure deviations and ensuring compliance with procedures, insufficient training, lack of an automatic emergency shutoff for the unloading process, poor ventilation system design, improper storage of and access to escape respirators, and insufficient communication between various parties, driver to operator, at plant shift change, to emergency responders and the hospital, and to the public. The CSB findings reaffirmed the need for facilities to pay careful attention to the design and operation of chemical transfer equipment to prevent similar events. We will now move on to the second case study. On April 2, 2014, a driver was scheduled to deliver ammonium sulfate to an unstaffed water treatment facility in Kitchener, Ontario. Ammonium sulfate was accidentally delivered into a sodium hypochlorite tank. The reaction was so violent, there was damage to the roof of a multi-story building. There were concerns that nitrogen trichloride, a reactive byproduct, was still present days after the explosion occurred. The incident received multi-day news coverage, and 12 days after the incident, there was initial speculation that the building would need to be demolished due to structural issues, but those were unfounded. Later, an estimated $800,000 would go to the water treatment plant for repairs. An investigation determined that the cause of the explosion was human error. A contractor accidentally pumped a chemical into the wrong tank, causing a reaction. The corrective actions that were taken included installing locked cabinets with correct signage and closing the delivery connections. Accidental mixing incidents often have similar contributing factors, including the 2 case studies we just reviewed. In summary, the following are common contributing factors in accidental mixing incidents. Storage tanks or connection points may not be labeled or marked correctly or at all. Connections for the different product storage tanks look the same. Insufficient or lack of documentation for the process of receiving and unloading of materials. And a lack of awareness by unloading of the potential catastrophic consequences of accidental mixing incidents. Additional factors that also contribute to accidental mixing include poor communication by unloading personnel due to complacency, interruptions, pushing to another task, shipping papers or labels may not be viewed thoroughly, the driver does not question or raise concerns with the plant operator, and inadequate training of delivery and receiving personnel. Next, we will watch a dramatic reenactment of an accidental mixing incident resulting in a tragic outcome.
Bye-bye, see you at tea time.
Bye-bye, don't forget to be safe.
I won't, give me a kiss. Bye, love. Hi, Chris. I've got sodium hypochlorite.
Look, I'm in a hurry. I've got kids coming in the next 5 minutes. You know where the connection is, don't you?
Yeah.
I'll be back in 5 minutes.
Wait up. There's no label on that connector. You sure that's the hypo, yeah?
Yeah, of course it is. Look, I've got to go.
I'll just proceed then. All right.
Get on with it. I'll sign your paperwork later, yeah?
Keep him under close observation, ventilate, transfer him to intensive care.
What happened to him?
I believe he was delivering sodium hypochlorite to a swimming pool. Connected to the wrong outlet, creating serious chlorine gassing and mass panic. The next 24 hours are crucial. He should make it, but you never know. He may recover physically, but I'm not sure how he's going to feel psychologically when he realises that his actions have caused fatalities. That's something he's going to have to live with for the rest of his life. You've thought his company would have had strict procedures to follow.
Bye-bye, don't forget to be safe.
Preventing accidental mixing incidents requires suppliers, customers, and drivers to take active precautions. Written procedures should be developed that employ verbal and visual confirmation between the delivery and receiver personnel. Employee training should be conducted. Active monitoring for compliance with the written procedure is essential. Let's review some suggested safeguards that can be taken. Extreme care should be taken to ensure cargo tank contents are properly identified. Verify the cargo tank contents by careful inspection of the bill of lading. Ensure that the chemical name, UN number, trailer number, and all placards match the bill of lading. If any doubt, notify the shipper for verification before continuing. Visually trace the pipe run from the connection point to the receiving tank to ensure the product is directed to the correct tank by matching the lading information with the tank labeling. If unable to confirm, or the piping goes to an unmarked storage tank, do not begin the transfer process and make appropriate communications to the customer and dispatch. During the transfer, the driver should maintain an unobstructed view of the unloading operation. Customers should locate sodium hypochlorite unloading connections away from incompatible product loading and unloading connections. Design piping to the minimum length that is needed to achieve a safe loading-unloading process. Piping should not be excessively long, which could unintentionally introduce other issues. Piping should be marked clearly so that the unloader can trace the product piping from the connection point to the receiving tank. Sodium hypochlorite unloading lines should be dedicated to avoid any compatibility issues. A lockout system should be considered to prevent accidental mixing. For customers designing new systems, consult with your supplier for design considerations. An inspection checklist that contains all the steps should be used by the customer for transfer operations. The checklist should be utilized to verify each step as it is completed. At a minimum, the following should be completed prior to the initiation of the transfer. Verifying the correct chemical by matching the UN number and chemical description on the bill of lading with the tank's contents. Ensuring that the certificate of analysis information matches the trailer number, if provided on the certificate of analysis, and the product name. Verifying other information on the bill of lading, such as the trailer number and security seal numbers. Confirming that the transfer hose is connected to the correct unloading line. Verifying that any common drain sump used for multiple products is empty, rinsed, and isolated prior to beginning the unloading process. And ensuring that the tank has sufficient capacity to hold the amount being delivered. Suppliers can put in place the following safeguards by utilizing a loading and unloading checklist, which should include verifying that trailers have the proper last contained or washout certificates, visually verifying that trailers are clean and empty or have only residual sodium hypochlorite prior to refilling, applying numbered seals and noting seal numbers on the bill of lading, and verifying that the proper placards are in place on the trailer and that they match the bill of lading. Other safeguards that suppliers should put in place include offering to train carriers and customers in safe handling practices, including the avoidance of mixing chemicals, utilizing a bulk delivery pre-qualification process that reviews the customer's site prior to the first delivery, periodically updating the bulk delivery qualification information through inspections of customers' facilities, encouraging drivers to raise safety concerns and ask questions, following up appropriately to driver concerns and questions. If a customer is not observing the delivery, additional precautions should be in place. Incorporating safety policies regarding bulk deliveries that empower drivers by providing strong management support and giving drivers stop work authority. It is important for suppliers to work with facilities and collaborate to develop or agree upon procedures for chemical unloading. The Chlorine Institute has many resources available to download related to accidental mixing. Please visit the CI website at www.chlorineinstitute.org to download Pamphlet 96, which includes useful information such as the resources listed here. Additional resources related to accidental mixing that can be found on the CI website include Sodium Hypochlorite Incompatibility Chart, available online in Spanish, the Hypo DVD, Handling Sodium Hypochlorite Safely, an accidental mixing poster, and a sodium hypochlorite customer's generic safety checklist, bulk users. The information contained in this video is drawn from sources believed to be reliable. The Institute and its members, jointly and severally, make no guarantee and assume no liability in connection with any of this information. Moreover, it should not be assumed that every acceptable procedure is included or that special circumstances may not warrant modified or additional procedures. The user should be aware that changing technology or regulations might require a change in the recommendations herein. Appropriate steps should be taken to ensure that the information is current when used. These suggestions should not be confused with federal, state, provincial, municipal, or insurance requirements, or with national fire, building, or safety codes. The Chlorine Institute exists to support the chlor-alkali industry in advancing safe, secure, environmentally compatible, and sustainable production, distribution, and use of its mission chemicals. CI's mission chemicals include chlorine, sodium and potassium hydroxides, sodium hypochlorite, the distribution of vinyl chloride monomer, VCM, and the distribution and use of hydrogen chloride. This support extends to giving continued attention to the security of chlorine handling operations. Chlorine Institute members are committed to adopting CI's safety and stewardship initiatives, including pamphlets, checklists, and incident sharing that will assist members in achieving measurable improvement.
That was the accidental mixing video. Let me switch to.
So the accidental mixing cannot be stressed strongly enough that we want to avoid that at all costs, because as we've seen in the Atchison, Kansas one, how devastating it can be. Thousands of people had to seek medical attention. So everybody, needs to be aware of that and try to avoid it at all costs. Preventing accidental mixing, a shared responsibility. Drivers should ensure that cargo tanks are properly identified, verify that chemical names and UN numbers and trailer numbers and all placards match that of the bill of lading, visually trace the pipeline from the connection point to the receiving tank. Do not begin any transfer process to an unmarked storage tank. Maintain an unobstructed view of the unloading operation. As that one driver was sitting in his truck, there's no way he could see the unloading process from sitting in the cab of his truck. Customers should verify the correct chemical by matching the UN numbers and on chemical description on the bill of lading with the tank and the contents. Ensure that the certificate of analysis information matches that of the trailer and the number and the product name. Verify trailer number and security seal numbers. Confirm transfer hose is connected to the correct unloading line. Verify that any common sump is empty, rinsed and isolated prior to the unloading process. Ensure the tank has sufficient capacity to hold the amount that's going to be unloaded. Suppliers should verify trailers have the proper last contained or washed out certificates. Should visually verify trailers are clean and empty and have only residual sodium hypochlorite prior to refilling. Apply numbered seals and note seal number on the bill of lading. Verify the proper placards are in place on the trailers to ensure they match the bill of lading. Encourage drivers to raise safety concerns and ask questions. For more information, visit theChlorineInstitute.com.
And this poster is available for download on the Chlorine Institute website, as well as the video that we just saw about accidental mixing. It's available through the Chlorine Institute at the Chlorine Institute's bookstore or on YouTube as well. We have a YouTube channel, and just go to YouTube, search for Chlorine Institute, and it'll take us to our channel. And this and many other videos are available to watch for free.
Okay, accidental release. In the event of an accidental release, isolate the source of the leak or spill. Contain the spill with compatible absorbent materials, sand, clay, vermilite, or commercial absorbents. Do not use a combustible material like sawdust. Containment system and prevent runoff to streams or sewer systems. Spill removal, reclaim and reuse if you can. Neutralize with sodium sulfite, bisulfite, or thiosulfite. Remove the liquid with a vacuum truck or place residue in a non-leaking container. Next slide. Caution, apply neutralizing agents cautiously. Sodium sulfite, bisulfite, or thiosulfite. Confirmed pH is adequate to prevent chlorine gas generation. The neutralization reaction will be exothermic. It's going to generate heat. Anytime you're trying to neutralize it, it's going to generate heat. Effervescence may result. Flush spill area with water. Note, only trained and properly equipped responders should perform this operation. Next slide. Additional.
Go ahead.
No, go ahead.
I was just going to mention for the additional training materials and resources, typically tie into the Chlorine Institute website, and just wanted to make you aware of. I've talked about some of the resources that are available. The specific Chlorine Institute resources on sodium hypochlorite are safety pamphlets, which we already talked about, 96. There are other safety pamphlets, but that's probably the best resource for sodium hypochlorite. There's the videos, some of the videos that we already saw, handling chlorine safely, and the accidental mixing video. The emergency kit booklets and videos are also available through the Chlorine Institute. And if you have a non-emergency technical question about your facility, your materials of construction, any type of engineering question, we can if we don't have the answer to it, or if our answer is not in our documentation and our resources, we can give you a list of consultants who are we keep a list of consultants who may be able to help. They're independent consultants, but that's yet another resource for you to to use. So these are some of the resources. There's other additional training information from other water sector organizations like the American Water Works Association, the Water Environment Federation, and the National Rural Water Association. We attend conferences. We attend actually, Earl, I believe you gave a presentation, or you attended one of the was a training event, right? Was it 2 years ago?
I did one down in Fort Lauderdale.
Fort Lauderdale, yeah.
Mm-hmm.
And that one, what was that one?
The same two we did here.
Okay.
Chlorine safety and sodium hypochlorite safety. Yeah.
Okay. Yeah. So in addition to the Chlorine Institute, there's other organizations, and since we're really it's not a competition at all. Those we promote and use some of the resources that other companies and other associations utilize, because our end goal is to prevent incidents involving chloralkali chemicals. So the safety data sheets which we already discussed, those you should be able to get from your supplier. And I just want to invite you to keep up with the Chlorine Institute on social media. We have a Facebook page, we have a Twitter account, we have a LinkedIn page as well, where we promote events or training like these, and some of them are remote. Recently they've been remote. Last year they were remote. This year we've been doing a lot of remote trainings due to the pandemic. So it's likely we'll still do that, and which means that you could utilize those resources, and that's where we announce them. So I invite you to go to the Chlorine Institute pages on all of these social media, and also on YouTube to watch some of these videos. And having said that, I was just, if are there any technical or non-technical questions? Feel free to use the chat feature on Zoom. Yeah, go ahead. Earl, were you gonna say something?
I was just going to say that during the accidental mixing video, they mentioned the Chemical Safety Board. And if you're not familiar with that, the United States government has a Chemical Safety Board that if the accident at a facility is bad enough, they will send a crew out to investigate how and why that accident happened. Now, they're not going to go out for every accident, but if it's a horrific accident, they're going to go out there and they'll do a full investigation of it to find out why and how it happened. And then you can go to their website, and there's accidents of like the old one in Atchison, Kansas, and you can read their detailed report, and you can also read the results of what they found. But there's also reports on there for chlorine leaks that have happened over the years. There's also investigations of petroleum and other items on there. But there are some reports on accidents that have happened in our field. So it's a good source to find out, maybe not what to do. This company didn't do this. They didn't label their lines, so maybe we should label our lines. So.
Absolutely. And we are currently actually, Earl, and we are working with some of our members to develop an accidental mixing resource. One of them, actually, and I have them here, includes the development of some labels. Like, I don't know if you can see on my screen, but which is this tag. I have a tag here that says sodium, let me see. You can see sodium hydroxide solution, 1824, the UN number there. It's hard to see because of my, let me try to remove my, the background.
We're still on the question page.
There's a question on the chat room.
Yeah.
Okay. Let me see.
Yeah, we're still seeing the last page of the slide.
Okay. Let me exit that. First, perhaps stop sharing. If I can stop sharing my video, I don't know if you can see my screen.
Yes,
now?
I can see you now.
Okay, so these are some of the labels that we're developing. This one says, for instance, sodium hydroxide solution. This other one says sodium hypochlorite solution. So, we're thinking of, mass producing these type of labels and distribute them to prevent accidental mixing incidents. Because as you saw, maybe a label as small and cheap as this one would have prevented that incident that we saw in the video where because it was not properly labeled, the truck driver accidentally hooked the line to a tank full of hydrochloric acid, or an acid. It was hydrochloric acid, I believe. So again, we're still developing resources to prevent accidental mixing incidents of these kind.
Somebody asked a question.
Yeah.
And it is sodium hypochlorite is only between 10 and 30%. Is that for every company or only certain ones? If a customer calls and says that they want 9%, that company or the manufacturer will probably make 9% for them. Some companies get 10.5%. Some of them get 11.5%. So, we try to make our solutions at the strength that the customer wants. So, just because it says between 10 and 30% in strength, you can get it in that range, and you can even get lower strengths than 10 if you wanted to. So hopefully that answers that question.
Earl, what would we consider, very high strength solution, sodium hypochlorite solution out in the industry?
I don't know. Mainly in like the state of Florida, most of our customers down here are using 10.5. I can say that in the state of Georgia, most of our customers up there are using 11.5. You know, we finally convinced the Florida customers that buying the stronger just causes it to go weaker quicker. So they were saving money by using 10.5. You know, so we would like to convince more people of that, you know, because it buys them longer shelf life. During the summer, you go through, our customers go through that product rather quickly, you know, and in the wintertime, that's when it sets in the storage tanks longer at the customer location, not at our facilities. So this bleach that everybody makes, it lasts longer in a cool environment. So you can imagine how quickly it's going to degrade during the summer months when the temperatures up there in the 80s and high humidity. So
Great, thank you very much.
Can household bleach be injected into potable water storage and what part per million? There's actually information out there on how to disinfect potable water with bleach, but and I don't have that information in front of me. But it is out there. You know, I do know that. So, and they will tell you how much to put in it in order to use it. Let's see. Yeah. Because someone was asking, you know, can household bleach be injected into potable water storage, and at what parts per million residue is recommended? Like I said, there is information out there on how to do that. I don't have it in front of me right now. And unfortunately, I'm getting old and don't keep all that information in my head anymore. Have you ever had customers who asked for higher than 30? No, I have not. The highest I think I had a customer ever request was 15%. And then when they got it, they immediately diluted it down. So why they even wanted it at 15 when they were immediately going to cut it in half, I don't know.
Or any other questions? And if not, or if you have questions later on after this webinar, you can certainly let us know, Ignatius, and we'll get them the answer.
Sure.
You're probably also wondering about your certificates. I received your list, Ignatius, of people who attended last week's certificates. Last week's webinar, and we'll put it together. We'll see, you know, who attended both, and
yeah. I'll send you the one for this week as well.
Excellent.
So somebody asked a question is regarding cooling towers. Is chlorine used as a shock treatment, or is there a recommended parts per million residue to maintain? It would be, and remember, it's not chlorine, it would be bleach that you're using, sodium hypochlorite. Okay. So, and yes, it would be used as a shock treatment.
Oh, and
right. Are there any other questions? If there are none, I'd like to thank Earl White, Mr. Earl White of the Allied Universal Corporation out of Florida, who is a chlor-alkali expert. And we really want to thank him for joining us again for the second session. And I trust that you thoroughly learned quite a bit, and that you will be able to use that knowledge back in your various utilities. But as indicated by Marco and Earl White, you can always go to the Chlorine Institute website. They have loads and loads of information, and as well as on their YouTube site. So I'd like to also thank you, Marco, for making this possible and for bringing on Mr. Earl White with us from the Allied Universal Corporation. For those of you who are just joining us for the first time, we said that last time 2 years ago, we hosted a face-to-face training in St. Lucia, and we had participants from around the region came into St. Lucia for that, which was hosted in collaboration with WASCO, the water utility in St. Lucia. And we looked at the various safety protocols. So always remember safety as shown in the video, and again, as stressed by Mr. Earl White and Marco. So I think we will be, of course, we are recording this, and please do visit the CAWASA site on YouTube. You would find under CAWASA Education, and you will find all the webinar sessions are posted there, and also on our Facebook page and our website. So thank you all for your participation. All of you out of from Jamaica all the way down to Trinidad, Barbados. I think all the islands are represented, St. Lucia, Dominica. I think we had from the BVI, Turks and Caicos, St. Vincent and the Grenadines. Thank you very much. I'm Ignatius John, the Executive Director.
Ignatius.
Thank you, Marco.
For inviting us. We love participating in these kind of training events. Like you said, a couple of years ago, we had an in-person training. We definitely look forward to returning to a normal and resuming those in-person trainings, and certainly hope to see some of you there attending these training events in the future.
I've got to say, gentlemen, I've enjoyed it. And if I can ever be of assistance to any of you, just let me know. The Chlorine Institute also knows how to get in touch with me, of course. But everyone be safe out there.
Yep.
Sometimes we do jobs for so long that, we get careless, or we think we know a shortcut. And we don't realize, like they didn't realize in Atchison, Kansas, that they could send thousands of people to the hospital, but they did, over something that was a simple mistake. Somebody didn't lock a line, and somebody unlocked another line and walked away, and the driver hooked up to the wrong line. So it's something that looked minor, turned into something really, really major. So let's try to be careful out there.
Earl, were you in the training in St. Lucia a couple of years ago?
I've been in training all over. I did one down in Slidell. I've done one over in Mississippi, over in Nashville, Tennessee. Yeah, I just go all over wherever they ask me to go.
Oh, okay, because whenever we resume these, we'll certainly ask the product stewardship issue team to and Greg Namoff and Allied to hopefully we can see each other in person in one of your beautiful islands in the amazing and gorgeous Caribbean.
I do everything from A kit, B kit, C kit, training and all of that, all emergency response. I do that. The emergency response video that's out there, I help edit it for this go around. We made changes to it. And so it's interesting that y'all should watch that video from the Chlorine Institute, because there has been some changes in it.
Okay.
Thank you, Earl. Appreciate you, Greg, and everyone at Allied for your sweat equity and being here and providing this type of training, making sure the chlor-alkali industry worldwide is well trained during these difficult times where the training has to be done this way.
All right.
And we look forward to seeing you in person pretty soon. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you, everyone. I'm Ignatius John, the Executive Director at the Caribbean Water and Sewage Association, thanking all of you and wishing you a safe return to wherever you are, or your homes, although most of you are already at home in cyberspace. But keep safe, from COVID-19 and follow the protocols so we can be around to continue delivering safe and high quality water to the people around the region and everywhere else. Thank you and good evening.
Thank you. Bye-bye.
Thank you. Bye.